Good day everyone, my name is Graphics. In this video, we will be looking at an aspect of statics which is Lami'S Theorem, where we'll be considering this question, and the question goes this way. It says a light string ABCDE whose extremity A is fixed as the weights W1 and W2 attached to it at B and C. It passes through a peg at D carrying a weight of 300 Newton at the free end E as shown in the figure. Now this is the figure. These are the points A, B, C, D and E along the string, right? Each of these string, due to the weight W1, W2 and the weight here at point E, which is 300 Newton, there will be a tension acting along this string. So there will be a tension along AB, we're going to call it TAB, right? There will be a tension along BC, we'll call it TBC, or you say TCB. Along CD, there will be a tension which we'll call TCD, or you call it TDC. Is that taken? And at this point here, the tension along this point is already given, which is called TDE, and that's given as what? 300 Newton. Is that taken now? So the next thing we're going to do here, we have a weight here, W1 and what, and W2, right? It's attached to. So the next thing we'll do is to draw out our free body diagram so that we're able to calculate the tension TAB, TBC, TCD, W1 and what, W2. So at joint B, because we have two joints here, joint B and joint C, so we're considering each of those joints, and the joint is a point where two or more force acts, right? So at joint B, this is what we'll be having here, right? Now we have the TAB, tension along AB. We have the W1 acting downward, and we have the what along the string BC. There's a tension TBC as shown here, right? And we have a force this way, which is what giving us 150 degree, and we have an angle at this point here, which is giving us what, 90 degree. Now if you look closely, in between TAB and W1 there's an angle, but we don't know what that angle is, so we need to find the angle in between TAB and W1. Now what you do is, I will draw the diagram here again, right? And this is what we have: my TAB acting along this axis, my TBC and my W1, and the angle between TAB and TBC is 150 degree. Now what I will do is, I will extend, using red line, I will extend my TBC to the other side, right? And I'm going to extend my W1 to upward. Is that taken? We know very well that, let me now take this up here to be the north, and let me take this here to be the west, right? Now if you look closely, the angle between the north here and TBC here is 90 degree, right? And the angle between TAB and the north here will be what, 90 minus 150, and that will give us what, 60 degree. So the angle between TAB and this vertical line here is given to be what, 60 degree. Now if you look closely again, the angle between the north here and the west here is given to be what, 90 also, and we have 60 degree in between 90. So if you want to know the angle between the TAB and what? And the west here, it will be 60 minus 90, and that'll give us what? 30 degree, right? And if you look here, that means the angle between TAB and the west here is what? 30 degree, right? Now, if you look closely again, the angle between the west here that is here and W12 is given to be 90 degree, right? This is the 90 here. Now, if I want to know the entire angle between TAB and W1 here, it will be 30 plus 90, and that'll give us what? 120 degree. So I'm going to write here now that what? The angle between TAB and W12 is given to be what? 120 degree. Is that okay now? Now, similarly, we'll consider joint C, and we'll have this. Is that taken? So we'll be having the tension along CB, which is also called TBC, or we say TCB, the same thing as the previous one, because they are acting at the same line. And we also have the tension TCD, right, which is equals to what? TDE, and that is given as what? 300 Newton. And we also have the weight acting downward, which is W2, and the angle at which TBC and TCD is inclined to each other is giving us 120 degree. Now, if you look closely, you will discover that in between TCD and W2, there is no angle, and we need to look for that angle. Just like we did in the previous joint, we are going to apply the same principle in this joint. Now I am going to withdraw to show you what is really happening. Now if you look at, we have TCB, we have TCD, and we have W2, and we have an angle of 120 degree between TBC and what? TCD, and we have an angle of 90 degree between TBC and W2. Now what I will do, I'll use a red line. I will extend TBC towards the right. This is what we have. And also extend W2 upward. This is what we have. So I'm going to name that upward line to be N, which represents my north, and the other one to be E, which represents what? My east. Now we know very well that between the north and the east that you have here is giving us what? 90 degree, right? We know very well that what? It is 90 degree. And we know the angle between north and what? And TBC is given to be what? 90 degree also. Now if that is the case, if you subtract the 90 that is in between north and the TBC from 120, you'll be left with what? 30. So it means that the angle between the TCD and the north here is given as what? 30 degree. Similarly, if you look at the angle between north and east, which we know it is what? 90 degree. If you subtract the 30 degree here from the 90 degree, the angle that will be left here will be what? 60 degree. Is that okay now? Now, if you now look, we know that between the W2 and the east here, which is E, is given to be what? 90. Now, if I want to know the force in between the TCD and W2, it will be the summation of the angle 60 and 90, and that will give us what? 150 degree. So it means that the angle between the TCD and the W2 is given as what? 150 degree. And I'm going to now write it there. And this is what we have. So this is this free body diagram that we have. That is the first thing you do. Now the next thing you do is there are different ways you actually attack this question, but in this video we'll be looking at what is called using the principle of the law of Lami'S theorem, right? So applying Lami'S theorem to joint C, right? Applying what? Lami'S theorem to joint C. And what is the law? The law states that the tension TCB divided by sine 150, which is the angle that is opposite the tension, like the angle in between the two other tension, which is 150 degree, is equals to TDC all over what? Sine 90, the angle the force divided by what? The angle opposite it equals to W2 over what? Sine 120. So what we just did here is what we call what? Lami's theorem. Now if you look at this, we say that we will now be looking at, we know that our TDC is given as 300. So I'll write it down there. Now we will now consider TDC over sine 90 equals to W2 over sine 120. So we're considering this. We'll consider every one of them. We cannot consider TCB over sine 150 equals to TDC over sine 90 because of what? We have, we cannot consider TCB over sine 150 equals to W2 over sine 120. Why? Because we don't know TCB and we don't know W2. So what we can consider, we can either take TCB over sine 150 equals to 300 over sine 90, or 300 over sine 90 is equals to what? W2 over sine 120, any of the two. But now we're considering the 300 over sine 90 is equals to W2 over sine 120 in order for me to get my W2. Now if you do the needful, we know very well that 300 over sine 90 is 1, so we'll be having 300 equals to W2 over, we know sine 120 is given as what? 0.8660, right? So if I cross multiply, W2 will be given as what? 300 times 0.8660, and that will be given as what? 259.81 Newton. So that is my W2. That is the force acting downward there. Now we'll now consider TCB all over sine 150 equals to 300 over what? Sine 90, right? So this is what we're considering now. Now my TCB over sine 150 is given as 0.5 equals to 300 over what? Sine 90 is 1. So if I write it, my TCB now will now be equals to 300. If I multiply, is it multiplied by what? 0.5. So my TCB here will be given as what? 115 Newton. So we've gotten TCB and what? And W2. Now if I input my value, if I now consider TCB over sine 150, now if I've gotten my TCB and my what? My W2, we're done with that. So we're now going to consider joint what? Joint B. And joint B is giving us, we have W1. If I apply Lami's theorem, we'll be having W1 over sine 150, right? The force, the angle opposite the force, is equals to TBC over sine 120, that is this over this, equals to TAB over what? Sine 90, right? And we now have, we know my TBC is gotten in the previous joint, which is what? 150. So I'll write it down there, is equals to TAB over sine 90. So that's what we have there. Now I will now consider W1 over sine 150 equals to 150 over sine 120 because I want to get W1, right? So when I do that, if I make W1 so that the formula, I'll be having 150 multiplied by sine 150. I'm taking sine 150 up here to multiply 150. So all over what? Sine 120. Now my W1 will now be equals to 150 sine 150 will give me 75 divided by sine 120 is 0.8660. So W1 here will now be given as what? 86.61 Newton. Now that is my W1. Now I will now consider 150 over sine 120 equals to TAB over what? Sine 90. Now if I make the TAB the side of the formula, we'll be having 150. I'm taking sine 90 upward here, so I'll be having 150 sine 90 over sine 120. And 150 sine 90 is 150 because sine 90 is 1. All over sine 120 is 0.866, right? So when you divide, you'll be having your TAB to be equals to what? 173.2 Newton. So now we've gotten all what is required to get in that system here. So we know that my W1 is equals to what? 86.61 Newton. my W2 is equals to 259.81 Newton. My TCB is equals to what? 150 Newton. My TAB is equals to 173.2 Newton, right? And these are the tension along the string. So if you have found this video helpful, please don't forget to subscribe, like, comment, and also share the video. Thanks for watching.